In this first section, we'll discuss cloud security testing within the cloud system or infrastructure. What is cloud system security testing? Cloud system security testing involves testing the cloud system's infrastructure. This includes cloud provider security policies, security controls, security procedures, and threat and vulnerability coverage. What is the purpose of cloud system security testing? Cloud system security testing's purpose is to provide validation that the system's infrastructure managed by a cloud service provider is secured according to shared security policies, controls, and procedures. Cloud system security testing also verifies that monitoring and alerting systems perform as expected. The overall goal is to ensure that business data is not accessible to or used by unauthorized users. So where should you begin? The importance of creating a test strategy at the start cannot be understated. Due to the complex nature of cloud system security testing, a pre-planned strategy is essential. Additionally, cloud system security testing must be scheduled with the cloud provider to ensure the availability of the test system. That includes accurate data and connected systems like APIs, databases, or messaging systems. Scheduling is not only necessary but ensures that monitoring and logging are enabled so they can be checked for data coming in from security and penetration testing efforts. So what are the basics of test strategy? Creating a test environment system for cloud system security testing is complex. Experts suggest creating at least 4 copies of the same test environment for different testing purposes. Deploying each system independently provides controlled test environments for functional security-based testing, penetration or attack-focused testing, performance testing, and compliance validation. Separate environments allow testing to occur without interfering with testing in other environments. What are the different types of testing techniques? There are several different types of testing techniques used in cloud system security testing. Functional security testing is executed against authentication, access control, permissions, security configuration settings, anti-attack and antivirus systems, and monitoring and alert accuracy. What are the testing techniques that simulate attack scenarios? Apart from the functional security testing, there are also separate testing efforts that focus on finding vulnerabilities in the infrastructure. The testing techniques that simulate attack scenarios include attack-focused testing, where testers attempt to gain unauthorized access to business data or cause a data breach. And penetration testing is where testers execute a variety of attack simulations looking for configuration errors, missing security protocols, and insecure coding practices. What is the performance testing technique? Performance testing is another testing technique for testing cloud system security. In this case, testers execute the following tests looking for vulnerabilities, including virtual machine I/O time. Are there significant time gaps that allow an intrusion? Attack filtering. This tests the handling of attacks and how much interruption filtering them causes the system. Defensive measures performance. When defensive measures are activated, what is the impact on users within the system? And monitoring and notification performance. How quickly do notifications and alerts reach the responsible resources? What is the compliance testing technique? Compliance testing is a technique used to validate if the infrastructure meets the organization's selected standards for cloud system security. Standards exist for each country around the globe, with several offering global security standards. For example, in the US, the NIST standards are published by the US government and cover a variety of security business applications. We will include references at the end of this webinar. Compliance testing includes testing that the organization or business has created the expected security protocols and rules within the cloud provider infrastructure, and as part of the shared security responsibilities with the business. In this next section, we are going to discuss security gaps. Despite the focus on system security, numerous common security gaps allow hackers or others to continue to circumvent security protocols. Some of the more common system security gaps include authentication and access management configuration errors. For example, misconfigured user permissions and weak credentials, skipping enabling MFAs, multi-factor authentication, misconfigured data storage buckets, for example, failure to encrypt data properly. Also, failure to configure for private and public data access. Insecure APIs. This could be either improper access controls or lack of input sanitation, server misconfigurations, and also outdated software. This could be improper, incomplete, or missing critical updates. Final two items for cloud system security gaps include insecure coding practices, SQL injection, XSS, cross-site scripting, CSRF, cross-site request forgery, and present encode handling connections and API data transfers. And the last item being security logging and monitoring failures. Alert notifications not generating, or alert notifications delayed, or third-party system failures cause non-delivery. When discussing cloud system security gaps, we should also discuss the dangers of misconfiguration. Notice the number of security gaps around misconfigured settings. Many security gaps revolve around improper cloud system infrastructure configuration. In fact, the number one issue in system security stems from misconfigured security configuration. Misconfiguration settings remain the number one method of gaining unauthorized access to a cloud system, resulting in a data breach. So, the importance of testing around both shared and business side configuration settings cannot be denied. Now, how does an organization test system security configuration? One option is a cloud security configuration review. This is typically performed under contract with an external provider. They can also execute security testing and note any configuration issues after testing completes. Additionally, they can use the cloud provider's manuals and go through each setting step by step, comparing to the system being tested. For example, if you're using Azure as a cloud provider, access documentation and specifications and walk through each one to compare setting values. What does a misconfigured setting look like, or what problems can it cause? Here's a couple of examples to visualize the dangers of misconfigured settings. In 2019, a hacker used a misconfigured firewall in the AWS system to steal 100 million plus customer records. How was it caught? Fellow hackers turned the person in after she bragged about the attack on social media, which means there was not only a misconfiguration in the firewall, but the intrusion was never tracked or logged, and no alerts were triggered because there was no monitoring configured on the system. Docker API vulnerabilities were found by hackers who manipulated the connection ports between the Docker API daemon and the Docker CLI and the API. When ports are not secured properly for the API, hackers can access the shared ports and take over the API. Unauthorized users can manipulate the REST Docker API to access the external daemon. Weak configurations in the APIs expose external connections that allow unauthorized users to access the API and the application data. What is penetration testing? Cloud system penetration testing finds vulnerabilities in the infrastructure system by executing controlled and monitored cyber attacks. Penetration testing within a cloud infrastructure must be scheduled and conducted under the guidelines of the cloud service provider. Plan time in the test strategy to include working with cloud system provider groups to enable sufficient access for cloud system penetration testing. Never conduct cloud system security testing without the legal consent and technical support of a cloud service provider. What are penetration testing techniques? These 3 standard testing techniques are used for cloud system penetration testing: black box, white box, and gray box. Let's go into more detail about these. Black box testing. It's used to simulate brute force attacks against the cloud system, and this testing simulates actions hackers take to gain access to source code and find susceptibility and infrastructure access details. White box testing. This is testing with full knowledge of infrastructure, access to source code, and software architecture. It uses software code analyzers, code debuggers, and scanning tools to attack all layers of the infrastructure. It looks for susceptibilities that are used to gain access to data, code, administrator configuration settings, or control systems. White box testing is most useful when details of the infrastructure are known to the tester. Gray box testing. This is when testers simulate an external attack manually checking for security holes. It simulates brute force attacks on the system using knowledge of the infrastructure. And automated tools scan for authentication details listed in files, and they gain access to configuration settings or administrator accounts for cloud system and connected databases. Gray box testing is useful when most, but not all of the details of the infrastructure are known to the tester. Social engineering, network services, wireless security, and API testing are types of penetration tests executed against a cloud system. Social engineering. This attempts to access the user information via phishing calls to IT support or IT staff. Network services. This is a test to find security holes that open access to the infrastructure. Wireless security. These tests identify alternative means of accessing the system infrastructure using low or no security Wi-Fi networks or hotspots. And API security. These tests attack API security when data is sent or received in transfer and during storage to a database. Most security susceptibilities and data breaches result from misconfigured system settings and inaccurate system monitoring. Penetration testing is used because it locates most security issues, but manual review is required for auditing of standard compliance and system monitoring accuracy. What are some of the security challenges for cloud systems? First, Lack of information. Cloud providers don't share all system infrastructure details, including the physical data locations or security policy settings. Resource sharing. Shared multi-tenant resources are common in cloud systems, and gaining access to other resources limits the ability to fully test. Last, policy restrictions. Many cloud providers restrict the scope of system security testing due to the complexity and integrated nature of shared resources. Cloud security system testing occurs rarely due to the complexity of test setup and access for testing using shared resources. In circumstances where testing the full infrastructure is not feasible, consider focusing testing on the business's system-side security. Shared responsibility models are common when working with cloud service providers. Perform system-side security testing on the business's share of the security at minimum for best results.